Dear students, so let us start our next chapter in chemistry, and the heading of the chapter is matter around us pure. Is the matter around us pure? Now, dear students, there are some words. Matter you have already came across this in the previous chapter. You came to know what is the matter. Anything which occupies space and has mass is called matter. Now, the next new word is pure. What is the meaning of pure? So first of all, we should have the concept of pure. What is the meaning of pure? In common language, if we use to say pure, that means a substance which is free from adulteration. Pure means, the literal meaning of pure is free from adulteration. Correct? Free from adulteration. Adulteration is mixing of other substances. Now let us take an example of substances across our surrounding. So milk, if we consider the example of milk, milk is a common substance or material or liquid which is used or which can be found easily in every household. Now, when the vendor, the milkman delivers you milk, what you need to say? It should be pure. Otherwise, I will not pay you. You cannot. You used to say, if your milk is not pure, I am not going to pay you. So, according to you, the pure means only milk and nothing else. That means nothing else means what? Water. That means the milk in common, the milk which is containing only milk and not water, you can say it is a pure in local consideration, local concept. But if we talk in scientific, this is local concept or common concept. Now, if we talk about scientific concept, this milk is not pure. Mind it, the milk which is pure, which is free from water, additional water, and can be said as pure in common concept, is not pure in the concept of chemistry or science. In the scientific way, this milk is not pure because this milk contains milk, water, protein, fat, etc. So this, let it be this water is the basic solvent in which these substances are there. So since if we analyze chemically this milk, it constitutes milk, water, protein, fat, calcium, and many more things are there. So scientifically, if we go to the purity, we cannot say that this milk is pure. Scientific concept. So, common concept and scientific concept are different. In common concept, a substance which is free from adulteration can be said as pure, but that is not true with the scientific concept. Then what is the meaning of pure in scientific concept? Let us discuss that. In scientific concept, pure means a substance containing only one type of particles is said to be pure. What is a substance which contains only one type of particles is said to be pure, and again particle you are very well known because we have read this particle in the previous chapter. So, in scientific concept, a particle which is free from adulteration simply can't be said as pure. In fact, a substance which contains only one type of particles are said to be pure. Let me give you an example. Consider any element such as oxygen, iron, etc. Since all the components or the particles of oxygen is the same, that is O. Likewise, all the particles of iron is same and nothing else than Fe. Hence, we can say this oxygen and iron are the pure substances. Otherwise, if it contains anything else, it could not be said. Even it is free from adulteration, we cannot say it pure in the scientific concept. Substances around us are mostly in the form of mixture. They are mostly in the form of mixture. Now, what is mixture? What is mixture? So, it is not a new word to you all. You very well know about mixture. Mixture is a combination of two or more substances. Mixture. Substances around us are mostly in the form of mixture, and mixture is a combination of two or more substances. Mixture is a combination of two or more substances. Now, let's have an example of air. Gas. Of course, you know very well, air is a combination of some gases such as nitrogen, oxygen, carbon dioxide, let me write it, CO2, and other gases. This other contains remaining gases, dust particles, and many more things. So, however, the percentage is almost fixed. This and this together constitute 1%. So let me write it 0.3%, and the remaining is this one. However, now in continuity we will learn about compounds. There you have to remember this point, which I will explain it there, because it will create confusion. However, substances in this air are in a fixed proportion, yet we are calling it air, and this is not satisfying the condition of compound or alloy. There is some difference between these 2 points. I will explain you later. However, air we used to say a mixture of different components, different gases. So now, thing which I want to explain you is that substances around us are mostly in the form of mixture, and this mixture is of mainly two types. Mixture is of two types. One is homogeneous, and other is heterogeneous. Homogeneous and heterogeneous. Now, this word is again not new to you. Homo and hetero. Homo means same. Homo means same, and hetero means different. Now, what is this homogeneous and heterogeneous mixture? What do you mean by this? To explain that, I have to erase it. Give me a second. Now consider two examples I am going to give you. This is a beaker or container. Okay, this is filled with water. Okay, suppose it is filled with water. Let me have another beaker of the same size and containing same amount of water. Okay. Now, in the first container, add some amount of sugar. Okay, let it add some sugar or salt. Okay, so now it will become a mixture. Then the sugar will completely dissolve in it, and in the second figure, put some sand in it. Sand or dust particle or soil particle, soil dust, chalk dust. Here you will use the chalk dust also, and mix it. After 2 minutes, 2 or 3 minutes, when you will go for the analysis, this sample of water which contain sugar or salt dissolved in water, let this sample taken from here or here or here or here or anywhere. The sample collected from the first beaker from different parts of the vessel will have same amount of sugar dissolved in it. Correct? Let it be either from here or from any part of the vessel which you have dissolved. I have taken 4 samples, suppose 1, 2, 3, 4, and about 5th one. Now, for analysis of these 5 samples, what you will come to know? The amount of sugar is same in all the samples. Correct? Now, let us come to the second example. Even though you have mixed it very well, okay, it was a dust particle or flour particle or chalk powder, after some time, when you are taking the samples of the same places which you have taken in the first example, now will all samples give the same composition or same amount of chalk powder or sand particles? No. Sand particles are not same everywhere. Hence, this type of mixture in which the components are not uniformly distributed. This technical word is used for especially this type of conditions, uniformly spread. Here the sugar molecules were uniformly spread all over the water, whereas here in the second example, the sand particles or the dust particles are not uniformly distributed at every part or every corner of the container or the water. Hence, we can say this is not a sample which is homogeneous. Hence, this is heterogeneous mixture, and this is homogeneous mixture. Now, I think the concept of homogeneous and heterogeneous has been clear to you. Before moving to the next, just watch this carefully.